Galaxy code architecture. Um, so we're going to talk about what happens after that request has reached the controller and it's handing it off to the business logic. So we're going to talk about the architecture surrounding the Galaxy components. So just a reminder, we're down here at this layer now, and we're talking about this box where a lot of interesting stuff is happening. So there's many different ways to think about what's happening in that box and how Galaxy processes requests and what sort of makes the Galaxy backend. But sort of one way you can visualize it is that the Galaxy database is the ultimate source for all Galaxy stuff, and the API controllers are the ultimate sink. And so in this architectural imagining of Galaxy, the managers are the layer meant to mediate all the interaction with the controllers and to isolate the backend from the web framework, while the model layer is meant to mediate all database interactions and isolate the backend from database internals. So we can sort of visualize that like this. We've got a request coming in through the API, hands it off to managers, which could talk to any different number of components to sort of do the work that it needs to do. Ultimately, though, those components are going to talk to the models, which is going to sort of mediate access to the database. Yeah, and so in this imagining of Galaxy, the managers are the top layer, and the models are the bottom lowest layer. If we think back to what we talked about, the Galaxy packages, everything in here, models and below, belong in Galaxy Data, like the Galaxy Data package. Everything from managers, I think these two layers here, managers and all of the components that make up managers and that are used, belong in the Galaxy App package. And the API controllers appear in the Galaxy Web Apps package. So that sort of reflects the sort of dependency structure we saw. The web apps depend on the app, and the app depends on Galaxy Data. So the flow is reflected there. Let's talk a little bit more about these managers. They're high-level business logic that ties the components together. Controllers should be thin. We mentioned that already. Maybe you're sort of asking yourself, if you've used models in other frameworks and you're looking at this, maybe you're asking, what logic belongs in the model and what belongs in a manager. So I like to think of it this way. Whenever the model requires more than just the database, then the operation is using some other external component, right? And so it should be defined in a manager instead of a model. So let's just, the managers are in libgalaxy managers. It's a directory, it contains all the Galaxy manager definitions. And they sort of correspond to what you might think they would correspond to, sort of Galaxy type objects. So citations, datasets, histories, HDAs are history dataset associations. So these are datasets attached to a history, collections attached to a history, pages, tools, workflows, jobs, visualizations, users, configuration. There are some helpers in this directory that sort of help these other things. Base has some useful mixins for building managers, so do a lot of these other files. Context provides sort of help build up that web transaction object that we mentioned earlier and provides context for the manager around history, user, and application during an action. Actions, objects that can be stored, use the shareable mixin, actions that can be tagged. If you've used Galaxy before, a lot of objects can be tagged, use the taggable mixin, annotations, things that can be deleted, things that can be rated, etc. So these managers leverage these mixins to sort of provide some common functionality. And that's the manager layer. I'll just briefly say that there are going to be some controllers in Galaxy that don't use managers. So there are controllers that talk to the application components directly. That's just the way Galaxy was architected for a long time. The managers are not brand new, but they're relatively new compared to the concepts in the models and some of the other components in the web app. So yeah, you find examples counter to this, but this is sort of the current best practice. On the far other end is the of the stack is the models, um, which are built on top of SQL Alchemy. Um, SQL Alchemy is an ORM, so it's an object relational mapper. So Galaxy doesn't think in terms of rows in a database, but in terms of objects. And so the ORM, or SQL Alchemy, is responsible for taking rows in the database and turning them into Galaxy objects. The classes these objects belong to are defined in libgalaxy models init. And how these classes map to the database columns and such are described in mapping files, in the mapping file libgalaxy model mapping. So it's the table definitions and then the relationships are both sort of described in that mapping file. SQL Alchemy has its object relational mapper, but it has some other useful concepts, and we make use of some of these. The engine is sort of the communication layer, I think. It's got an expression language for describing SQL in a more safe fashion, and there are places where you sort of many places in the code for performance reasons, we sort of skip the ORM and build SQL directly. And generally, we use this expression engine. Yeah. So the way that Galaxy builds up the database, it doesn't just sort of take a fresh database and put all of its models in, because Galaxy is an entity that has evolved over time and continues to evolve. So the database is built up via database migrations. So migration describes these migrations are a linear list of database diffs, essentially. And then after the last diff, you sort of end up with the current Galaxy model for the release that you're on. They allow the schema to be migrated forward automatically. They're powered by SQL Alchemy Migrate. Here's a link. And there's these migrations are in libgalaxy model migrate versions. The file name of the files in here just describe, the first part, the prefix, describes the ordering of the models, not the models, of the migrations. And then you sort of give a short description for what's happening. You could check those out. This is the Galaxy database diagram as of a few years ago. I hope that's useful. The full link is here. It's a lot to process. I'm going to go through a couple of key parts of the model, but we could spend days just talking about this, I'm sure. So the sort of key concept in Galaxy is histories and data sets. If you've used Galaxy at all, you know that. The history is that list of data sets on the right-hand panel when you are in the Analysis tab of Galaxy. The history actually isn't composed of data sets directly, but of history data set associations. So the data set represents the physical file, where it's located on disk, which object stored in. But the history dataset association has stuff like the DB key it corresponds to, the extension it is, the metadata corresponding to that extension. And if you think about that, you might change the extension of a file. You might change the DB key. You might clone the dataset and change the file type, because something more specific, for instance. And all of those may correspond to the same physical file. And so this is why the history dataset association is not the dataset, because when you can copy the history dataset association around, but we only keep one copy of the dataset. There's metadata in the database also, as well as the job that created the dataset. Here are some of the fields on here. So again, any number of history dataset associations can correspond to one dataset. The dataset has the object store ID, the external file name, the extra files path, the file size. So attributes about the physical file on disk, whereas the metadata, it's the HID, this is the position it is in the history, the state, the name of the file, something the user might change. All of that is stored on the history dataset association. Hope that makes some sense. We add dataset metadata, it's key value pairs attached to the HDA. These are sort of typed and defined at the data set, at the data type level. Can be used by tools to sort of dynamically control the tool form, provide some extra data to the user. That's data sets. We also have collections. So history can have these data set associations, or you can have collections. I mean, you can have both, right? So every history data set association, every history data set collection association belongs to one history, but history can have any number of these. And the way the history data set collection association works is a lot like the history data set association, in that it's got this history bound component that's mutable, but then it has a data set collection, which is write once. It's not immutable, but it's write once. So it's got a collection type which has elements. The elements have an identifier and an index, and you could have more sub collections, so you have nested collections, and or the elements can themselves be history data set associations. So that's stuff in histories. Another big component of Galaxy is workflows. In the database, we have a distinction between a stored workflow and a workflow. So you might go into the workflow editor, change the workflow, and save it. And that's the user doesn't see a different object on screen, a different entity, but that's because what the user is exposed to is the stored workflow. But the stored workflow has any number of workflows associated with it. And these are sort of a chain of them over time. As you save workflows, you sort of replace the old workflow with a new one that's associated with the stored workflow. But we do keep the old workflows around because, for provenance, right? We need to understand, if we look at workflow implication, what the definition of the workflow was at the time of execution. And so these workflow objects can have any number of workflow steps. And each of these steps, and so the workflow step is a database entity, but it corresponds to a workflow module in Python code. And we'll talk more about this when we get into the nitty-gritty of sort of some non-model objects. So that's the definition of the workflow. When you actually run it, what happens? Well, the workflow, we create a workflow invocation corresponding to the workflow. And the workflow invocation has any number of workflow step invocations, and each of them have one or more jobs, and the jobs produce data sets and run tools. Libraries are a little bit more like histories. You've got different your library has any number of library folders which are recursive. The library folders have library data sets. And the library dataset has actually a level of indirection that the histories don't. So the library dataset and library dataset association, yes, that's dataset twice, are both sort of handle different aspects of what the history dataset association does. But the idea here is that you might have, a library dataset that has a fixed name over time, but you might want to update new data. And so in the older version of the GUI, you could do that. We don't really do that anymore. We don't really expose that concept anymore because I think we want to sort of simplify the model that we're exposing to the user. But you've got two objects as a result that sort of both contain some metadata on top of the data set. And that metadata is sort of placed inside of a library folder. We've got some permissions on top of library folders, different kinds of actions. Can you manage the library folder? Can you read the library folder? And these are sort of, you got roles and users, roles corresponding to users and groups that sort of handle these permissions. And that is it for now for the models and managers.